Questions 3, 4, and 5 are allowing us to practice understanding function notation and how to simplify things that are written that way. So for question 3, it says for f at x equal to negative 4x plus 7, find each value. So again, this is just my fancy equation. So it's saying my function rule is negative 4x plus 7. This means that whatever my value is that I'm going to plug in, I'm going to multiply it by negative 4 and then add 7, and that's going to give me my output. So A says find f at 2. So function notation here, this is just a really easy way of saying, think about what we did in that first week of school with evaluating. Function notation here, it's really just saying, I'm trying to make my pen smaller. It's really just saying evaluate y equals negative 4x plus 7 when x equals 2. It's just the same thing. Again, as we go further in mathematics and you take more and more advanced classes, eventually we just like to shorthand everything and use a bunch of numbers and symbols, which is all function notation is doing. It's taking your regular equation that you're used to seeing, y equals negative 4x plus 7, and it's replacing it with different notation so that instead of writing out evaluate y equals negative 4x plus 7 when x equals 2, we can just say find f at 2. Because what that means is that I'm going to take this 2 and plug it in for x. So f at 2 is equal to negative 4 times 2 plus, 7. So now you're just evaluating orders of operation. Multiplication comes first. Negative 4 times 2 is negative 8 plus 7. Negative 8 plus 7, remember your rules. Subtract to keep a bigger sign, so I get negative 1. So f at 2 is equal to negative 1. So that meant if I was graphing it or if I was talking about that coordinate point, my x value would be 2 and my y value would be negative 1. Again, function notation is just a really fancy way of all of the stuff that we did a couple weeks ago with evaluating. B says 6 minus f at 5. So as we're doing these function notation problems, if you're thinking in terms of orders of operation, you always want to evaluate your function rule first. So that whole 6 minus part, I'm going to save until I actually figure out what f at 5 is. And remember, that's just a fancy way of saying evaluate y equals negative 4x plus 7 when x equals, in this case, 5. So f at 5, let's do that part first, is equal to negative 4 x, negative 4 times 5 plus 7. Multiply first, so I get negative 20 plus 7, negative 20 plus 7, subtract them, 13, but keep the negative sign. So f at 5 is equal to negative 13. But now my whole rule here, or my whole piece to simplify, says we'll take 6 minus f at 5. So if f at 5 is equal to negative 13, now I'm going to take that whole negative 13 and plug it in, paying careful attention to the fact that I haven't used the subtraction sign yet. So step 1 was to find that f at 5. Step 2 is to now simplify everything. And again, I didn't use 6 or minus. All I did was determine that f at 5 was equal to negative 13. So now I'm going to plug that in, and I'm going to remember how to subtract two negatives. 6 minus negative 13 is the same as 6 plus 13, which is going to give me 19. So again, if I was graphing this, my coordinate point would be just for my function. So 5, my output is negative 13. However, this extra stuff is not part of my coordinate point. My coordinate point only comes from my function. Alrighty, so I have two letter B's. So let's come over to here. Now I have f at negative 3 plus 1. So again, if we're thinking in terms of orders of operation, only simplify that function rule first. And again, just a really fancy way. It's just asking us in shorthand, evaluate y equals negative 4x plus 7 when x equals negative 3 in this case. So we're going to do the same thing. Figure out f at negative 3. So that means take negative 4 times negative 3 plus 7. Negative 4 times negative 3, 12 plus 7. Well, 12 plus 7 is 19. But again, all I did here was simplify f at negative 3. I had that extra piece of my rule here. So this is my first step. Second step is to now plug in and evaluate the whole expression. So it's f at negative 3 plus 1. So if f at negative 3 is 19 plus 1, my final answer is going to be 20. Now to finish up with part D, I have a lot going on here. I have 2 function rules and I have a negative out front. But again, just go step by step. Our first step here is to evaluate my function rules. So the first thing I'm going to do is calculate, well, what is f at negative 1? Not worrying about anything out front, not worrying about everything out back. I just want to figure out what is f at negative 1. So that's going to be step 1. F at negative 1, again, just a fancy way to say, well, what is negative 4 times negative 1 plus 7? Negative 4 times negative 1 is 4 plus 7 is 11. I'm going to take it one step further and figure out my second function rule. So there's just a couple more steps in this one. So now I want to figure out what f at 2 is. F at 2 is negative 4 times 2 plus 7, which is negative 8 plus 7, which is going to be 1. So now I'm just going to plug into the whole expression because I've already figured out both of my function rules. So my final expression says take a negative f at negative 1. So what is the opposite of f at negative 1? F at negative 1 was 11. So the opposite of that would be negative 11. Plus f at 2, which is 1. So my final step, I'm going to simplify. Negative 11 plus 1 gives me negative 10. So that was your straightforward examples, plugging in numbers. Down below, we're going to get a little bit more abstract. Take a look, see if you can figure both of these out, and then watch that second video to walk it through with me.